Hi guys, welcome to 12.5, dividing polynomials. Alright, to divide a polynomial by a monomial, divide each term of the polynomial by the monomial. So for example 1, whoopsie, close my pen. Maybe I'll try putting my book in my lap. That might help me. Alright, so for example 1, we have the expression 3r squared minus 15r, and that quantity is being divided by 3r. So what we're going to do here, we could do what we did in our previous lesson, put this over 1, flip them, or we can do what we simply know to be true. That if we're dividing 3r squared minus 15r by 3, we'll just put 3r squared minus 15r on top, and we'll put 3r on the bottom to represent our division, and then we can just simply cancel things out. Or we can split the terms underneath the common denominator. This can now become 3r squared over 3r minus 15r over 3r. If we're looking at our first set, 3 over 3 cancels out. R squared over r, 2 minus 1 is just 1, so we end up with r. Everything else canceled out. 15 and 3 goes into 15 5 times, 3 cancels out. And our r's cancel out, so we're left with 5 over 1, or just 5. So our simplified expression is r minus 5. Now let's look at example 2. Example number 2, we have the quantity n squared plus 10n plus 12 is being divided by 5n. So again, we're going to go ahead, put it 5n squared plus 10n plus 12 on top with 5n underneath. So we're going to get n squared plus 10n plus 12 all over 5n. And now we're going to split it up and start our canceling again. We're going to have n squared over 5n, which is our common denominator, plus 10n over 5n plus 12 over 5n. And we can start simplifying. This is really a 1. 1 and 5, nothing cancels out, so we're just going to be left with those. But we're left with n squared and an n. 2 minus 1 is 1, so we're going to be left with a single n. So we have, and it's going to be this n that cancels out. This is going to become just a single n. So we're going to have 1n, or just n up top, and then our n down below canceled out, and we're left with just a 5. So we're going to have the fraction 5n plus 5 goes into 10 twice, and our n's cancel out, so plus 2 plus, and now here we have 12 and 5 and an n. 12 over 5 doesn't really reduce, and we don't want to turn it to an improper fraction, so we're just going to leave it as 12 over 5. Nothing can be reduced in that again, and nothing can cancel out with that n. So when we divide the polynomial n squared plus 10n plus 12 divided by 5n, we put it over top of each other, and then we just work independently. N squared over 5n, and we cancel out anything we can. Unfortunately, we can only cancel out 1n, and again, we're left with 1/5, or 1n over 5. Our second term, our middle one, was much easier. Our 5 and our 10 canceled out just to give us a quantity of 2. Both ends canceled out, so we're left with 2. And our last term we couldn't do anything to, so we left it as that, and it was a little bit easier. Alright, example 3. Divide polynomials by binomials. You can use algebra to do this. Recall from lesson 12.4 that when you factor, some divisors can be formed easily. Just meaning once you factor something, you can always look for things to cancel out. Example number 3. We have the quantity of s squared plus 6s minus 7 is being divided by s plus 7. Alright, if we're looking here to factor, we have a negative 7 but a positive 6. How do we get a negative factor? That means one has to be positive, one has to be negative. And when we add a positive and a negative together, it has to be a positive 6. That means we need a positive 7 and a negative 1. Positive 7 times negative 1 is negative 7, but 7 minus 1 is 6. So our factors here are going to be s plus 7, s minus 1, all being divided by s plus 7. And now this is similar to our last week's lesson, or not last week's lesson, our Monday's lesson, and we just cancel out our common factors. We cancel out our s plus 7, and we're left with a final answer of s minus 1. And that's our final answer. Alright, now on to the next page, which is all about long division of polynomials, which I think is pretty fun, but it requires some steps. We're going to divide, we're going to multiply, then we're going to subtract. And these 3 steps are going to be the same for every part of the division of a polynomial. Subtract. Alright. In example 3, the division could be performed easily by dividing a common factor. However, when you cannot factor, you can use long division process similar to the one you use in arithmetic. So example 4, long division. So basically what they're saying is if you can't factor, you can't cancel anything out, what do? You have to use long division. And again, it's very similar to what we did in elementary school, but it adds some steps into it, which kind of makes it fun. So again, for every step, every term, you're going to divide, you're going to multiply, then you're going to subtract. So for example 4, we have the term x squared plus 3x minus 24 is going to be divided by by x minus 4. So we're going to set it up like a normal long division problem where this is going to go on the inside of our division box. We have x squared plus 3x minus 24 is being divided by x minus 4. And so, again, every time we go through this for each number, we always divide, multiply, subtract, repeat, divide, multiply, subtract. But the only number you're dividing with is going to be your x. So let's see what I'm talking about. Division only happens with your first term, and we're going to see what happens with that negative 4. It will get included, but we only divide with our leading term, which is x. So we're saying x squared divided by x equals what? Or alternatively, you can ask yourself, x times what equals x squared? Well, x to the first times x to the first equals x squared, because remember we add our exponents. So x times what equals x squared? Just x, a single x. And now this is when you multiply. So we divided by x, and now you're going to multiply by x, your original divisor. So I'm going to take x, and I'm going to multiply it by both x and negative 4. So x times x is x squared. It's a way of double checking your work. And then x times negative 4 is going to be negative 4x. So again, step 1 is I divided by x into my first term. Step 2 is I multiplied x by my binomial on the outside. And now I'm going to subtract the entire quantity. And this is when you want to just be very careful. So x squared minus x squared cancels out. And now 3x minus a minus 4 becomes addition. 3 plus 4 is 7x. And now I have my next step into this. And I'm going to repeat. I need to ask myself, x minus 4 goes into 7x how many times? Remember, I'm only actually dividing by x. X goes into 7x how many times? Or x times what equals 7x? Well, x times 7. So x times a positive 7 equals x, or 7x. Now I'm going to multiply. I'm going to take my 7, or not my 7, yes, my 7, sorry. And I'm going to multiply it by x and by negative 4. And I'm going to carry down my 24, sorry. Just like in normal subtraction, bring it down. So I'm going to have 7 times x is 7x. I'm going to have 7 times negative 24, which is going to be negative 28. And now I'm going to subtract. 7 minus 7x is going to cancel out. And now I have negative 24 minus a minus 28, so that's going to turn to positive. Negative 24 plus 28 is 4. And now I have no other terms to bring down. That's my remainder. So if we look up top, I have my divisor, I have my answer, or I have my quotient, I guess. But I have a remainder of 4. If you remember from elementary school, what do we do with our remainder? We put it over our divisor. So my quotient so far is x plus 7. And then I have a remainder. So and or plus, we'll put an and here. And 4 over, what was my divisor? X minus 4. And that is long division of polynomials. Example 5 shows us what to do when a polynomial is missing a term. So let's look at that. So for example 5, we have a cubed plus 8a. And now this is what they mean missing a term. We have a to the third, a to the first, but we don't have an a squared. Minus 24 is now being divided by a minus 2. So again, rewrite with your leading term inside the box. A to the third plus, and now this is where it matters. So we should have an a squared, correct? Because we want it to be in descending order, a to the third, a to the second, a to the first. But we don't have an a to the second. So I'm going to put in a 0 times a to the second. And I can do this because 0 times what, or 0 times anything is just 0. It doesn't exist. So putting this in just creates a placeholder for me, while at the same time it doesn't change my problem because 0 times a squared is still just 0. It's nothing. So now plus 8. A to the first, or just a, so 2, 3, 1, or 3, 2, 1, sorry, minus 24, all on the inside, a minus 2 on the outside. And we're going to follow our same 3 steps of divide, multiply, subtract. And remember, every time we're only dividing by a, and then once we get our number up top, we multiply that by a and 2. So I need to ask myself, a times what equals a cubed, and that's going to be a squared. And I always space over 1 and put it over the number that it matches, a squared over my a squared. And again, how did I get that? A to the first times what equals a to the third? Well, a squared. 1 plus 2 is 3. And now I'm going to multiply that back to my original problem. So I have a squared, and I'm going to multiply it times a, and I'm going to multiply a squared minus 2. So a squared minus a is going to be a to the third. A squared minus 2a is going to be a negative 2a squared. And I'm going to subtract this entire quantity. A cubed minus A cubed cancels out. Now 0 minus a minus 2 becomes addition. 0 plus 2a squared is just going to be 2a squared. And now I have my next term, and I'm going to drop my next one. I always want to be working with two things down here. So plus 8a. Now I need to ask myself, a goes into 2a squared how many times? Or a times what equals 2a squared? So a times what equals 2a squared? Well, that has to be 2a. A times a is a squared, 2 times 1 is 2. So that means up top, I have a positive 2a. That's my missing factor. And now, because I've divided, I'm going to multiply. I need to multiply 2a by my outside polynomial. So 2a times a is going to be 2a squared. 2a times a negative 2 is going to be negative 4a. I'm going to erase that line. So I multiplied, now I'm going to subtract, and I'm subtracting the entire quantity. 2a squared minus 2a squared cancels out. And now I have 8a minus a minus 4a. Turn that to addition. 8 plus 4 is 12a. So I have my next value that I'm looking at. And then I'm going to bring down this negative 24 because I want two values. But again, this is the one I'm looking at. I need to say a goes into 12a how many times? A times what equals 12a? Well, a times 12 equals 12a. So my value is a goes into 12a a positive 12 times. And now bring down your 24 so you have your two terms that you're working with. It's a negative 24. So now I'm going to multiply. I've already done my division for this one, so now I have to do my multiplication and my subtraction. So 12 times a, 12 times negative 2. 12 times a is 12a. 12 times negative 2 is negative 24. And I'm going to subtract the entire quantity. 12a minus 12a cancels out. And now I have negative 24 minus a minus 24. Turn that to addition. Negative 24 plus 24 is 0. So I have no remainder left, and I was able to figure it out. A cubed plus 8a minus 24 divided by a minus 2 is equal to a squared plus 2a plus 12. And I have solved this problem with long division. Alright, good work, guys. I will probably film another video of me doing 2 more examples of these because I know it can be tricky. Once you get into the habit of it, it goes really quickly. It's actually kind of fun, and it's just kind of this pattern that you repeat. Divide, multiply, subtract, divide, multiply, subtract. And I think they're kind of fun, especially if, again, you like patterns, you like a logical approach to things. But I also know it can be kind of tricky when you're first doing it, so I'll probably film a video of me doing 2 others. If you have a good hang of it, obviously no need to watch, but it's just extra material. Alright guys, have a great day.